is principal focus. Principal focus, which is denoted by F. Now principal focus for concave mirror and how the principal focus is formed for convex mirror we will see. Now for concave mirror, this is the non-reflecting surface and this is the reflecting surface. Concave mirror. This is the non-reflecting surface for convex mirror. This is pole. This is the principal axis. This is the center of curvature, and here also the center of curvature. Now, the next definition is our principal focus. Now, as some rays are incident, parallel rays are incident on a concave mirror. Suppose these are the light rays incident on a concave mirror. These are the parallel light rays incident on a concave mirror. Now, as these light rays are incident on a reflecting surface of a concave mirror, they reflected from this reflecting surface and they reflected back and intersect at one point on the principal axis like this. So this is the reflecting, this is the incident ray, and this is the reflected ray. So this ray is incident on the concave mirror and it get reflected. So this is also the incident ray and it get reflected at this point. So these are the reflected rays, and all these reflected rays are intersect at one point on the principal axis. So at one point on the principal axis, and that point of intersection is called as principal focus. So as the parallel light rays are incident on a concave mirror, then they get reflected and intersect at one point on principal axis, and that point of intersection is called as principal focus for the concave mirror. And for concave mirror, principal focus is always in front of the mirror. So what is principal focus? For concave mirror, principal focus is nothing but as the parallel light rays incident on a concave mirror, the reflected rays intersect at one point on the principal axis. That point of intersection is called as principal focus for concave mirror. This is called principal focus for concave mirror. Now what do you mean by principal focus for convex mirror? Now this is the reflecting surface for convex mirror. So how the rays are incident on a convex mirror? These are the parallel light rays, or the light rays which are parallel. These are the light rays parallel to the principal axis. So these are the incident rays, light rays. Now as the light rays are incident on the reflecting surface of a convex mirror, then these light rays appear to come from, after reflection, it appear to come from one point. So this is this incident on the reflecting surface of a concave mirror, and it appear to come from a one point like this. means this incident on a concave mirror and get reflected back, incident on a concave mirror and get reflected back, incident on a incident on a convex mirror and get reflect back. Here also incident on a convex mirror and get reflect back. But when it reflect back, it appears to come from one point on the principal axis, and that point is called as principal focus for a convex mirror. So what do you mean by principal focus for a convex mirror? So as the parallel light rays incident on a convex mirror, then the reflected rays are appear to come from, and here the reflected rays intersect at one point. So that is the difference between convex mirror and the concave mirror and the convex mirror. In a concave mirror, the reflected light rays intersect at one point, and in a convex mirror, the reflected rays appear to come from a one point from a principal axis, and that point is called as principal focus for a convex mirror. So in both the cases, the point of intersection or the point from which the light rays are appear to come from one point on the principal axis, that is called as principal focus. In case of concave mirror, the principal focus is in front of the mirror, and in case of convex mirror, the principal focus is behind the mirror. So what is the principal focus for convex mirror? That is, as the parallel light rays incident on a convex mirror, the reflected rays are appear to come from a one point on the principal axis, and that point is called as principal focus. So as the parallel light rays incident on a convex mirror, the reflected rays appear to come from a one point on the principal axis. That point is called as principal focus. So that point is called as principal focus. So what do you mean by principal focus? In case of convex mirror, and in case of concave mirror. So in case of concave mirror, the reflected light rays are intersect at one point, and in case of convex mirror, the reflected rays are appear to come from a one point, and that point of intersection is called as principal focus. So, and that principal focus is denoted by F. So hope you understand what you mean by the principal focus. Now the next definition is, what do you mean by focal length? Now, this is the fifth and this is sixth definition, that is focal length. Now what do you mean by focal length? And this focal length is denoted by small f. This is the important term related with the spherical mirror, that is focal length, which is denoted by small f. Now what do you mean by focal length? Focal length is nothing but the distance between pole and the principal focus. Distance between pole and the center of curvature, that is called radius of curvature, and the distance between pole and principal focus in both the cases, that is called as focal length. Here also, in case of convex mirror, the distance between pole and principal focus is called as focal length, and distance between pole and center of curvature is called as radius of curvature. So always keep in mind these two distances. What do you mean by the focal length and what do you mean by the radius of curvature? Radius of curvature is distance between PC, and focal length means distance between PF. So focal length means distance between pole and principal focus is called as focal length. Is called as focal length of the mirror. Focal length of the mirror. So though it is concave or convex, and it is denoted by small f. Now if we consider an activity, that is hold a concave mirror in one hand and hold a sheet first hold a concave mirror in a hand and direct it towards the sun in such a way that the reflected light rays are incident on the sheet of paper which you hold in another hand. So in another hand you hold a sheet of paper, and this concave mirror are adjust in such a way that is the reflected light rays from that concave mirror are incident on the paper. And now adjust the paper in such a way that the reflected light rays form a sharp bright spot on the paper. And now hold the concave mirror and the paper when we get the sharp bright spot on the paper for a few minutes. Then what you observe? You observe that first the paper produces the smoke, and eventually after some time that paper catches the fire. So why this is so? This is because of that bright spot which is formed by the concave mirror on the paper. Now that bright sharp bright spot is nothing but the image of the sun formed on the paper. And after some time, when we hold both the position of the paper and the mirror for some time, so that bright spot catches fire, because all the reflected rays all the reflected light rays are concentrated at one point, and as it concentrate at one point, the heat produces, and due to that heat, that paper produces the smoke and catch fire. So that bright spot is nothing but the image of the sun which produce on the paper, and now the distance of the image and that concave mirror gives the approximate value of the focal length of that mirror. So in this way also we can easily find the approximate value of focal length of the concave mirror. So that bright spot is nothing but the image of the sun formed on the paper and the concave mirror, and the distance between them gives the focal length, and that is it. That is nothing but that focal length, that is the distance between pole and the principal focus, that is called the focal length of that mirror. And the next definition, seventh definition, is the aperture. Seventh is aperture. Now what do you mean by aperture? Aperture is nothing but the small portion of the spherical mirror which is exposed to the incident rays of the light rays, that is called the aperture. So this is, for example, this is the reflecting surface. So this reflecting surface is exposed to incident the light rays, and therefore we called it as the aperture. So M, if we name it M dash, so M dash is the aperture of the mirror, because this is the portion which is exposed to incident the light rays. So the portion which is exposed to incident light rays is called as aperture. So aperture means M here in case of concave mirror. Suppose we say that M dash. So M dash is the aperture, because this is the portion which is exposed to incident the light rays. So that is called as aperture. So these are the 7 important terms related with spherical mirror. First is the pole, then center of curvature, radius of curvature, principal axis, principal focus, focal length, and aperture. First we will see pole. Pole is nothing but the center of the reflecting surface of the mirror, that is called as pole. Then center of curvature means the reflecting surface forms a sphere with center C, and that center C is called as center of curvature. The distance between pole and the center of curvature is called as radius of curvature, which is denoted by R. Then the line passing through pole and the center of curvature is called as principal axis. Then we will see what do you mean by focus. Focus is nothing but the point of intersection on the principal axis of reflected light rays, or the light rays are appear to come from a one point. That point of intersection is called as principal focus, which is denoted by F. In case of concave mirror, center of curvature and principal focus are always in front of the mirror. In case of convex mirror, principal focus and center of curvature are always behind the mirror. Then focal length is nothing but the distance between pole and the principal focus, that is called the focal length. And aperture is nothing but the small portion which is exposed to incident the light rays, that is called as aperture. So these are the seven important terms or 7 important definitions which are related with the spherical mirrors, and these definitions are also important according to the exam point of view also. Then the relation, what is the relation between radius of curvature and the principal focus? Now from this also we can see here, this is the radius of curvature. Distance between PC is the radius of curvature, and distance between pole and the focus is the focal length. So here also we can see that this is the radius of curvature and its half is the principal focus, is the focal length. So or this portion we called it as focal length. So this is focal length and this portion is called as radius of curvature. So here from the diagram also we can see that the radius of curvature is double of the principal focus, double of the focal length, or we can say that the focal length is half of the radius of curvature. So what is the relation between radius of curvature and focal length? So this relation is very important, and that relation is R is equal to 2F. That is, radius of curvature is always double of the focal length. So here also from the diagram also we can say that the radius of curvature is double of its focal length. So radius of curvature is also double of its focal length, or we can say that focal length is half of the radius of curvature. Any one of the relation we can use, or we also say that the focal length is half of the radius of curvature. So this is the important relation between the radius of curvature and the focal length. So R is equal to 2F, or F is equal to R by 2. So this is an important relation between radius of curvature and focal length that we are used in a numerical also, or when we draw the images formed by the concave mirror and convex mirror also. So hope you understand all these 7 terms and the relation between radius of curvature and focal length. Thank you.